Okay, this video is actually getting into some of the more advanced GIS analysis work that you can do as a landscape architect that will really help inform your site inventory and analysis, improve your grading, help us understand and do a better job with working with stormwater management, right? And it's really what we're looking at right here in front of us is that, I showed you in a previous video, I showed you this landscape and I showed you how we've gone ahead in this scene and we've dropped our hillshade over the top of a 3D model. And we've got slope actually, hiding there in the background very faintly in terms of that's what the colors represent. And then you've got the contours, and now I've added this new information. And you see this blue running down through here. And I will tell you that not every single one of these blue lines is a creek or a stream, right? Realistically, what we're just talking about is really how does water flow down a hillside based on where it falls. And it depends on the topography, and you can see that happening here. There's a ridge that comes right down here, and all the water on this side is flowing in this direction. All the water on the other side is flowing down this direction. Yes, they come down and meet, and somewhere downstream here, I'm sure that all of these little pools of water coming across the landscape are eventually, and you can probably start to see it, start to embed in the landscape right there and become the beginning of a stream, right? But that's, this is what we're aiming for in stormwater analysis. And so I want to keep today really simple. I'm not asking you to run through this. You're more than welcome to do this if you're interested in kind of working through the process with me. But it's not required just because it takes a lot of processing time. And there are certainly failures that happen just within the normal GIS workflow. So I want to step you through this process, and basically the way things work on this is that let's go back into my map view, and I'm going to go ahead and turn off a couple of things real quick. There we go. All right, so I'm in my map view. I have my digital elevation model for the Mount Rushmore area. I still have the contours on and labeled, right? It's just to help me. This is where we would start typically as landscape architects. But again, the complexity of what you just saw there and how water moves down the hill is something that we haven't spent enough time understanding, especially when we are the professionals often tasked with stormwater management at a site scale. And so being able to have GIS support us not just to understand the site, but to understand the surrounding hydrological landscape. These are important tools for us. But what I'm going to show you is basically a three-step process, and those steps are relatively straightforward. They're here in the hydrology toolbox. Now, for some reason, they didn't label them as step 1, step 2, step 3, which I find amusing. But here underneath the hydrology toolbox, we're basically going to go in, we're going to start with fill. We are then going to move to flow direction, and then we are going to move back up to flow accumulation. Now, there are definitely times and instances and more complex analyses that are going to use flow distance, flow length, sink, stream length, all of these features. The other thing that is hiding here in the hydrology toolbox, I will tell you, is a basin tool that will actually go through and figure out at a site scale where are all of the basins where water is going to come together and fill up. Basically, where is water going to accumulate on your site? You're going to see where that data comes from. We're not going to work with that here today, but I just wanted to point out that that is another one that might be useful to you moving forward. You can also get into some storage capacity. Again, this is starting to push our technical abilities. If you don't understand how storage capacity works, it's very difficult to then have GIS model it for you. And so you have to do some extra learning to be conversant and be able to use this tool. But for general flow patterns across the landscape, there's no reason we shouldn't just follow the three-step process that I'm showing you right now. And I'm just going to walk you through. I've already run these, and so I'm going to walk you through this process. And the process basically looks like this, is that we're going to take our digital elevation model, and the first thing we're going to do to it is that we're going to run the fill tool. So the fill tool, well, I'll walk you through the tools in more detail here in just a second. Let me walk through all of this first. The fill tool that I'm showing you here, right? All that this does is it goes through and it modifies the original digital elevation model to prepare that data for doing a stormwater analysis. And what it's doing is that there are lots and lots of micro errors in your digital elevation model. And I want to show you one of those errors right now. Sometimes there are big errors. this one has a big error in it. And so one of the things that the model couldn't figure out here is that it couldn't figure out that there is a culvert underneath this road. And so what you see here is that all of this is looking correct, all of this is looking correct, and then right here where you get all these straight lines, it doesn't know where the water is going. It can't figure out what's happening because it really should be flowing right through here, through a culvert, and on down the canyon, right? That's what the topography says. If I look at it from here, you would expect all of that water to roll here. Instead, what you are definitely seeing is an error in the model. Water does not go uphill. Just one of those basic rules. Anyway, jumping back here, this is part of making that correction. And again, it's not perfect, but it does fix a lot of what I will call the strange occurrences that pop up. Once we move on from the fill, we're going to go ahead and move on to flow direction. And so what the input data into this analysis is going to be our hydro fill. We'll go in. From that, what you're seeing here are calculations, again, at that, if I zoom all the way in here, 1 foot by 1 foot grid, it is determining where water is flowing out of each one of these grid cells. So it is performing tens of thousands of calculations for you to figure out how water flows downhill, all rapidly assessed for you. Ultimately, then we move in here to flow accumulation, which doesn't look like much, right? And I'm going to go ahead and step back and walk you through the process and then come back and show you. You start to see kind of down here, it's showing you where the water flows out of the landscape is really what you're seeing here. Show you how to go ahead and correct this and get it back to something that looks more like what I've got loaded in ArcScene. It's just a matter of symbology. We've got to go ahead and put the go ahead and make some corrections for what you're seeing here. All right, to go ahead and walk our way through the process, we've got, so we're going to start, we're going to go ahead and start with fill. And so we're working with our DEM. If I go into DEM, go into fill, I'm going to go ahead and I'm going to load my DEM, and I'm going to tell it where I want it to save. I will tell you that I almost always record it this way: Mount Rushmore, Hydro 1, fill. And so I'm filling in that's step 1, and then I'm labeling it so I don't forget it, right? And then I'm going to go ahead and hit run. This doesn't crash that often, but it may, and so you may have to use some of your workarounds. Go to the C drive. You may have to, it's possible in worst case scenarios that you may have to go back to ArcMap in order to run this. But anyway, that's the step. You're going to go ahead and let it run. I'm going to go ahead and just skip through that process, and so it created my fill layer, and we talked about how this doesn't look a lot different. After I do that, I need to go ahead and create flow direction. Now here's the important step is that now that I've got step 1, I need to put that, and I'm working on step 2, I need to put that hydro fill, that DEM fill in here. And then again, I need to label this out. And so for me, again, I'm going to label this out as Mount Rushmore Hydro 2. And then I'm going to fill this in as flow direction, right? I don't need to change any of these other features here, except in small, when you're working on a really small site and you get some weird things, you might want to come in and try clicking this button, and it can help you out. All right, you hit run and you wait for this to process. Again, the processing time on this varies, but somewhere between 3 and 30 minutes is not uncommon for running these tools. All right, I'm going to go ahead and step back again. So the result that comes out of what I just ran is this flow direction layer. Underneath flow direction, I'm now going to move to flow accumulation. So this is the last step in our process. Again, the important thing is that I need to go ahead and make sure that to do step 3, I need to add step 2 in as my input. Once I'm here, I can go ahead and label this out as Mount Rushmore Hydro 3 flow accumulation, right? Again, there's lots of other things that we can add to this, right, to enhance this, but this is definitely one of those. Things that you can just leave the inputs alone. If you want to go learn more and explore about them, you can actually do it through help, and it will give you lots more information. But there's also amazing videos out there online if you want to learn more about running models that have like a weighted raster underneath them, which would be something else that is influencing how water moves downhill. Again, I'm going to hit run, right? This is going to take, again, 3 to 30 minutes, and I'm going to get something like this, and you're going to go, why in the world did we spend all of that time and energy getting to something like this? And the answer is really simple, is that this just is a poorly, flow accumulation here is just a poorly represented version of what we're looking at. So what I'm really looking to do is I'm really looking to classify this layer, right? And it's going to take a minute to go ahead and run this. It's going to do it as based on natural breaks. There's a lot of different ways to going about doing this, right? You can start to see that I get a little bit more information starting to show up. And if I really want to see what I'm looking at, I can always turn off the lowest category. What it's going to do is it's going to get rid of that background. Yeah, I want it no color, right? It's going to get rid of all of that background yellow. And what I'm going to see in the landscape is that I can start following how water is moving, working my way back up into the landscape. Again, it's going to stop at some point though. And the reason it's stopping is because of my symbology. So I could actually crank this up and tell it, I want all 32 classes, give me everything. And again, I'm going to go down to the original, or the very smallest number, what I would call the flat part of the landscape. And I'm going to go ahead and get rid of that. And you can see that now I can chase this line work up into the landscape, right? And that's ultimately what we're looking for. But again, this just doesn't look that great. So really what I'm going to do is that I'm actually going to change up how I'm doing this. I'm going to go to manual intervals. And I'm going to take a look at that. It said, right, it says something about that low category that we've been working with is 0 to 15,000. Maybe that's a decent place to start for us. And actually, hold on, I got to do something first. What I'm actually going to do is once I've got that 15,000, I'm going to leave it on natural breaks. And instead of 32 classes, what if I come down and just tell it 2? Force it to come down, right, and represent the landscape this way. Again, I've now lost a lot of that detail, right? And the reason is that this upper value got reset from 15,000 to over 100,000. And we don't need to get into the nitty-gritty details of what these values represent, other than the fact that it's hiding data from you that you want to see. And so here's my solution to that, is that you go to manual interval. Remember, we knew this was 15,000 a minute ago. And I'm going to go ahead and let that start to populate. And while it's doing that, I'm going to change that to no color. And I'm going to change the second category to a really dark blue, and let that go ahead and process. Then I'm going to start to zoom out a little bit. All right. And then kind of come back in and take a look at it. And you can see that I've restored some of the data, right? And so again, I'm getting good information. But what if instead of 15,000, what if I put the number in as 1? And it's going to keep running this. And if I put the number in as 1, what you see is now it'll show me flow path lines for everything in the landscape. It's a mess is what it really is, right? And so what I want to do here is that I've got to find the right value for my drawing, and whatever scale I'm working at, whatever, however accurate the resolution is, you're going to keep working with this until you find something that you are comfortable with explaining as water, this is how water flows across my site. I just set it to 1,000. That's getting pretty close to what I showed you in the other drawing. I think the actual number that I came up with in the other one was 600, if I remember correctly. But all I'm really doing is eliminating the flat areas from being represented, and anywhere that is on an angle or starting to accumulate water, I want to be able to show that pathway. And so here it is. You can see this. You can make it more or less complex based on your needs and your desire to show different pathways across the landscape. But this is stormwater analysis, and I think this is an incredibly important tool for each and every one of you moving forward as landscape architects.